everyone. Thank you for attending today's webinar, Understanding the Risks and Limitations of Solutions Without DC Optimization. I'm Kelly Pickerel, editor of Solar Power World, and before we get started, I wanted to go over a few housekeeping items. You can view the slides for today's presentation in the resource window on your screen, and you can submit any questions related to today's webinar in the Q&A window. If we do not get to your question, our presenters may reach out to you afterwards. And finally, if you're watching this on demand, you can still use all of these features, including asking questions for our presenters. So let's get started with the webinar. The UL 3741 standard for photovoltaic hazard control is a flexible standard that makes use of both MLPE and non-MLPE solutions inside the PV array. Originally, the standard was created to ensure that firefighters are fully protected from energized PV arrays. Since its introduction in 2020, the industry has seen some suppliers come to market with non-MLPE solutions. While these solutions are NEC compliant, there are concerns that they offer only minimal protection for fully equipped firefighters. These solutions may use traditional string inverters to de-energize AC conductors, but the DC array remains at high voltage levels even during rapid shutdown. This represents a step back in industry safety, and the risks associated with solutions without DC optimization for UL 3741 compliance need to be debated. So today we will hear from Bill Brooks of Brooks Engineering, retired Fire Lieutenant Anthony Granato, Jason Bobruk of SolarEdge, and David Wolfert Jr. with EDPR. Today, our webinar panel will cover topics such as compliance with codes and standards, design considerations, and the risks posed to firefighters and O&M workers when working around rooftop arrays. And now I'm going to turn things over to Jason to kick us off.
Hi, thank you, Kelly. Just pause for a moment. We've got some noise outside here. I think it's passed. So I'm very excited to be here today with our panelists. We've got industry experts at the top of their field. I'm going to let them introduce themselves and take a few minutes to discuss, first of all, their experience in the industry and some of the challenges and successes that they see with the evolution of NEC and rapid shutdown and the new PV hazard control systems that we're seeing come to market, and then we'll circle back and have a discussion. Thank you. Bill, let's let you go first, Mr. Bill Brooks.
All righty. Well, thanks, Jason. Bill Brooks, been in the industry for a full 35 years. There wasn't really much of an industry back when I started in 1988. But have seen really and been involved with the evolution of the industry since I would call day one from a utility interactive inverter kind of standpoint with the utilities, working with utility interconnected systems, of course, in the 1980s. Almost all systems with the exception of a few in laboratories were mostly off-grid systems, which is where PV really got its great start. And so over the last 35 years, been involved with the electrical code and improving the process for safety and reliability of systems through codes and standards. And so been heavily involved in the code, National Electrical Code since the early 1990s. Been teaching code for about that long, and also been heavily involved in the standards, including UL 3741, which we're focusing on today. And it's important to understand that there's a lot of history behind this standard and how we got here. And I was involved in overseeing the firefighter task force for photovoltaics, which included several members of the fire service and solar industry. And we worked through a lot of issues, and that's when the concepts behind rapid shutdown, which was really designed for firefighter safety, to improve safety on rooftops for firefighters operating around PV systems, came along, and that progressed. And then the idea of having a standard, a UL standard, whereby we could have methods that were performance related rather than prescriptive. So that's the two different ways of doing standards. We can prescribe, you got to do this, 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 and this. You got to do it every time. You got to do it this way. Or you could have a performance standard that says, if you do these things and have this in your instructions and provide these barriers and these things, then it has an equivalent level of safety. And that's throughout the codes, that issue is there. And so there's been a lot of controversy, obviously, around rapid shutdown, 690.12. Firefighters, they just want to turn stuff off, but PV just doesn't work that way. And so originally we had the 80 volt threshold. That was a conservative number. We pulled it from the arc fault detection requirements, and it was kind of a placeholder. But it actually has worked out really well. And then we also had this option 3, we like to call it, where we said that, well, inside the array, if you didn't have grounded metal, then and your conductors were concealed so nobody could get to them, then those two things would provide a much lower hazard environment, and that would be acceptable as well. And in the last code cycle, we got rid of that option 3 and essentially folded it into what was intended to be part of 3741. So that idea of a listed array was really where 3741 came from. And so now we're in the process of applying the standard. Standard is probably, of all the standards, and I work on dozens of standards committees, it's probably the most complicated of all the standards that we work with from the standpoint of how to be able to apply it. And therein is the issue. And that's why we have some great products that are now on the market in 3741 that are taking advantage of the options for risk, to reduce the risk. And then we're seeing some installations or some designs that have received certification that, in my personal opinion, I believe shouldn't have. And I believe that mistakes were made. And that's okay. By the way, the sky is not falling. And that's really the message that I would like to put out there, is that the sky is not falling. However, if we don't address these problems that are currently coming out, then we're going to see everyone gravitate towards solutions that really should have never passed in the first place. And so that's where we need to kind of bring things back to a little more balance. And so that the products that are out there that are doing a great job, the designs that are doing a great job, are able to continue and be used, and those that are out of compliance, they understand how they're out of compliance and why, and with maybe some fairly minor modifications can come back in compliance. So that's kind of the world as I see it. I'll throw the ball back to Jason, and happy to answer questions as we dive in.
Great, thank you, Bill. So, wow, that's a great, comprehensive view of everything. And, I just wanted to also say, I didn't say this in the introduction, but we have 3 members from the STP for 3741 in this session, myself, Bill, and Tony. And we have 2 members from NEC's CMP4, Bill and Tony, that write, the section 690 for PV systems. And not to count David out, but David is the Associate Director of Safety at EDP Renewables, and he's installed some of the largest rooftop systems on top S&P 500 companies. So I think we have a really good, rounded panel here with lots of different perspectives. So I'm excited for us to keep going. David, why don't we let you go next?
Sure, sure. So thanks everybody on the panel and thanks everybody in the audience for joining today. Very, very happy that there's this much interest, and we're very happy to, help people and educate people. So my name is David Wolfert. I'm Associate Director of Engineering and Safety for EDPR Renewables. I've been in the renewable business and specifically solar for about 15 years now. And my role has been, as I look back, mostly like an owner's engineer, right? The systems that we're building and operating is something that we typically are owning, and therefore we want to make sure that they're operating reliably and safely for the lifetime of the system. And there's a lot that potentially goes into that, and I'm usually the person that's making sure that I'm taking lessons learned from older projects and making sure we don't repeat them. And I mentioned education because that's one of the challenges I think in this industry. Is it's a growing industry. It's a very fast industry. Everyone wants to get into this industry. Dare I say I'm a little older when I'm on a panel with someone like Bill, who's had as much experience as he has. But we've seen a lot of things. We've seen a lot of evolution of technology, and it's really just educating our installers and our customers, and even the teams that I'm working with, just to make sure that everything is installed properly and installed correctly. And what that means to me is, and throughout the career, I've made it a point. I never hold back knowledge, right? I want people to learn what I've learned. I'm not stingy, and I like to share my knowledge. I typically hold lunch and learns at my company, whether it's a biz dev person, a finance person that might not have much technical background, or, somebody on the O&M side that I say, hey, we're doing this, and this is why we're doing it. And, there's been a lot of good feedback that people just want to understand. And that goes out to our customers and our installers as well. We go as far as we actually have on-site training on proper install techniques, because with as many people as there are in the industry, and even some of the veterans in the industry, we still see things that are done incorrectly. And it's because we have two different teams out there. This team can do it this way, but this team does it this way. And making sure everybody's doing it the same and doing it correctly is very important, regardless of how many teams of people we have. Sorry, my computer just glitched a little. Can you guys still hear me? I think. Anyway, so
Gotcha.
Like I mentioned, we actually go as far as to have on-site training to go over install techniques. And even on our drawings, we go as far as to even specify certain components as far as AC disconnect brands, because there's some that we've had failures on that just, and when I look at the designs, I'm like, I don't know how that even passed any type of compliance or QA/QC, but we see it happen. Even with wiring, wiring, I've seen, wires break apart, they brittle in your hands, they change color. It's like, and this is after a very, very short period of time. And sometimes before the system's even energized or waiting for PTO, these things start to degrade. The example I like to also bring up too is like a Staubli connector, right? And fabrication techniques. Everybody, I hope, and I'm sure a lot of people on this call have either made connectors in the field or familiar with making connectors in the field. I want to ask you, how many people have actually attended a Staubli training? Because no one takes that into consideration. They use the little red wrenches, right? And I'm sure everybody's seen those. The little red wrenches actually don't provide the right torque. We actually need a socket that actually torques the connectors that you're making properly. And, we go as far as to specify those kits. And when we go out on site and we're doing these trainings, we want to see that actual kit on site so that we know everything's being manufactured, being installed correctly. We'll have companies such as SolarEdge even come out. They'll do on-site training for installers, just to go over best practices. And, with all of that, what happens is the system then becomes inherently much safer, and it becomes more reliable. And, I can sleep at night by not having to worry that I always say, an HVAC technician who is now on the rooftop and can't get to his compressors because it's populated with solar comes through and with his 300-pound compressor, because he has to change something out on a unit, and is now barreling over conduit and wire trays because he's upset that he can't get to his equipment properly, because of course no one's put in ramps. We put in ramps, but we want to make things easier for everybody that's going up on the roof in order to keep the integrity of our arrays. So that's why it's not necessarily just the installers, right? You can have great installs, and there's installs that don't have MLPE that are operating fine in the world, in the country. We understand that. We've got technology now that helps mitigate against these things. So the question is, like, why wouldn't we use that, right? Why would I want to compromise the safety of a fire department or people even inside the building with something that's inherently less safe? We want to make sure our systems are operating properly, and in the event that there is animal nesting or somebody up there hitting something that they did on accident that we don't know about, or even wind blowing something over. We've had cable trays accidentally blow over, and we don't have to worry about that because quite honestly, we've got SolarEdge on our roofs, and if something like that happens, we're safe and we're at safe voltages. And I'd like to say that we've got over 50 megawatts installed on rooftops. That equates to approximately over 62,000 optimizers, and we've not had one single thermal event happen. So we're obviously doing something right, and we're gonna keep doing it that way, because that's what's been proven, and that works, and that makes me able to sleep at night.
Thank you, David. Great perspective from the installation standpoint. And last but not least, Mr. Tony.
All right, thank you. Hello, everyone. My name is Tony Granato. I'm a retired firefighter lieutenant out of Connecticut. My original background was in the electrical field. I've held an electrical E2 journeyman's license since 1989, and worked on a few early PV systems with a contractor that I had worked for. And then I spent the last 31 plus years in the fire service. While in the fire service, I hold a few different roles. I'm the principal rep for NFPA 70 on Code Panel 4 with Bill Brooks and a lot of other very knowledgeable people. I joined that panel as having a voice for the firefighters across the country, career and volunteer. I felt if I could get in there and my main focus being the safety for our members across the country, and sitting on these panels and meetings after meetings and giving my point of view and the firefighters' point of view, it was very important to me. I've sat through 2 cycles so far of the NEC, and we're going into our 3rd cycle starting January. I also, as stated, am on the standard 3741 as well as 1741. In the past 10 years, my main focus, especially since I retired, is to educate the fire service in PV safety. So I've developed a few programs, and I travel the country teaching the firefighters and educating them on PV safety, mainly with 690 and building and ground mounted systems. And throughout the years, with the implementation of rapid shutdown in 14 and then the improvements in 17, and it keeps improving. The firefighters seem to be a little confused when you start to explain the systems. Now they have the legacy system that's prior to 14 that has no rapid shutdown. And then you explain what 2014 gives them, what 2017 gives them. And now we're entering a whole new area of the PV hazard control. So now I have to step in and, explain to them where we're going with this one. The issue I see is with the 80 volt option that we have now, it's pretty simple for the firefighters. They look at it in a higher voltage system being 600 or 1,000. And then when you talk about rapid shutdown, dropping it down to 80 volts within the array boundary, a lot of them look at that decrease as, hey, this is really safe for me. But now with some of these newer systems that are going through the standard, we could go right back up to the 600, the 1,000 volts within the array and now we have to re-educate them. There's really no sign that says which system is presenting which electrical voltage to them. So it's a lot of education there on our point. I'm one person that teaches across the country, and we've only touched a very small portion of firefighters. But I feel it's important, and I will keep doing this as long as I can. I'll stay involved with these panels, and I'm thankful that SolarEdge and some of these other groups have jumped on and have brought the firefighters in. I'm very appreciative that they let us speak our mind and have some say in the way this direction's going.
Great. Thank you so much, Tony. That's a great point of view, and we appreciate you doing all the training. So I'm going to circle back now with a couple of questions. I didn't do an introduction for myself. This is really more about our panelists. I'll do a quick one so people that don't know me. Been in the industry now, too many years. I think I'm going on 16 years. Director of Code Compliance for SolarEdge. Been in standards developments in various aspects of the industry, from grid codes, grid performance, all the way down to device certification, including rapid shutdown and PV hazard control. And I sit on several STPs and code making panels, not the NEC, but other codes. And I've known a lot of these folks, and several folks in our audience I see posting questions for a while. And that's it. I'm not going to go into an in-depth one. So let's circle back around with our panelists now. And I took a few notes. So I heard a couple of reoccurring themes. It sounds like there's an opportunity to improve. There's an opportunity for education. There may be some other things too that I didn't think about. If you had, and I'll let each panelist answer this individually. We'll mix up the order this time. We'll let Dave, who wants to go first this time? Let you go first this time. If you had a magic wand and you could change something, and we'll keep it bound to kind of, let's call it NEC and PV hazard control. If you could change that, or what would you do?
Okay, so I have to stick to that. I can't say like we're all living on an island and drinking pina coladas and don't have to pay taxes or anything like that. I guess
I'm trying to get there. Yeah, I've got the island.
Yeah, all right. I'll stick to the topic at hand then. But yeah, my magical thing that I would say again is it relates back to what I talked about in the intro is I really strive to have repeatability and success in that repeatability across multi projects and multiple portfolios that we're either owning or buying. You can tell a lot when you go out to a site, and I always say when you walk on site, one of the first things I look at is wire management. And you can tell real fast, just in my opinion at least, when I go out to site and those wires are very neatly tucked away and they took the time to put the clips and, there's not things dangling all over the place. And they've really taken the time to make it look like a quality install. That usually dictates what the rest of the project is going to be too, right? Because if they've taken the time to do that, they've probably taken the time to torque everything properly, do everything properly. We think, right? Now that has come back at me from time to time, but it's an indication of the level of quality of the install, which again, that's what really dictates this code, in my opinion, right? Is, you can have the most quality install, but that doesn't really matter, right? In the grand scheme of things, when it's going under operation, and it's not just the installers that are up on that roof. So, my magic wand would be, everyone can read my mind and do things the way I want them done, or the way I have seen in the past that's been safe and successful. And I can't always. That obviously is not going to happen. So again, the way we get around that, and I almost look at this, specifically the SolarEdge solution as an insurance policy, right? I don't have to worry that someone did something wrong. I'll give you a good example, just reverse biasing even, right? And, I don't know how many people have experienced that, but, and sometimes it's not seen for a while, right? But when we write our commissioning standards, we write them in a way that there are multiple layers that could potentially catch these issues before they become problematic, right? Measuring open circuit voltage, obviously, yes, right? But then you miss the minus sign. So then, there's then IV curve tracing. Okay, you can IV curve trace, and people go up to their DC disconnects and they have all the fuses open and they hook up positive, negative, close a fuse, hit the button, that comes back, everything looks fine. Then they get to string 4, and what happens is, that's reverse bias. So the people testing it just reverse the leads and then take the string measurement and then put it back and say, make sure you tell the installer that string 4 is reverse biased. And then no one goes and tells the installer. It gets lost. The people are off site. They end up closing the combiner box. They turn it on. It smokes. Maybe they notice it. Maybe they don't. But, at the end, then what we also do to ensure that we know if anybody has done anything like that is we actually amp clamp each single string to make sure it's providing the appropriate amount of current. Now, I've seen numerous times, unfortunately, where we've had reverse bias situations and they've caused failures. Now, the fuse is supposed to blow, but it usually ends up melting the whole terminal block. So, that just doesn't work. And then the whole inverter needs to be replaced, or the whole DC combiner needs to be replaced, or, whatever the case. And I've also had the same thing happen with SolarEdge. And guess what happens? Nothing. I just know that the string isn't on. And when I asked the guys, I said, I think you got reverse bias. No, we checked everything. I said, check again. And they went back and they said, oh, yeah, you're right. And you know what they did? They just flipped the wires and everything worked. And I had no faults. I had no reverse bias currents flowing and blowing up and potentially blowing up the bypass diodes of the other strings of the other modules because, they reverse bias. So, But people don't necessarily take the time to do all those things, right? They're under the gun. They want to save cost, So, if everybody could just, going back to the question, the magic wand, right? Like, I just want people to be understanding of what the situations are and be able to debug things correctly and make sure that they're turning things on, commissioning things, and making sure everything's operating safely in the way that was intended. And like I said, with SolarEdge, it's an insurance policy where if somebody does make a mistake now, we don't have a catastrophic failure. So, it's an easy decision for us. And that's something that we've standardized on a long time ago, even before the code came into play, because I saw this coming and, I can't sleep at night knowing that on a rooftop where there's, kids in a school that I'm worried that, somebody stepped on a wire, causing a ground fault. It's with SolarEdge, we don't have that issue, so we're going to keep using it.
Thanks, David. Good stuff there. Tony, we'll let you go next since Bill went first last time. We'll put him last this time. So, magic wand, what would you like to see changed?
As I said, my main focus has been the safety side for our members nationwide. And if I was to just come out with a magic wand, we always use the word standard, and in the fire service, a standard is something that's simple and repeatable across the board. If we could just come up with one set voltage, and let's say whatever that number is, and we could teach these guys that this is where we're at when you shut things down and when you're interacting with these damaged systems, that would be great. I know it's probably not going to happen. It's a real big far wish list, but that would be to eliminate the confusion across the board from the last 6-9 years of changing voltages and not knowing what they're dealing with on the roof. That's what I'd really like to see. One other thing I'd like to see, and again, the magic wand is a national code adoption where every state is adopting the same cycle at the same time. There is so many different cycles out there right now. When I'm teaching somewhere, I look up prior to going there to see what cycle of the NEC they're on, just so I can explain to them at what level of protection that the NEC has provided for them. So like I said, a national adoption, will we ever see that? Who knows? But that'd be another great improvement. But from the eyes of safety, that's where I'd go. As far as like the technical aspect, I'll leave that up to the rest of those guys, Bill and Dave and Dan.
Thanks. Great. I see I'm sensing some common themes here. So, Bill, we'll let you wrap it up, and feel free to take your time. You can have 5-7 minutes if you want. Because after this, we're going to jump into questions.
So what was the question again, Jason?
If you had a magical wand, and we'll got to keep it bounded for Bill, right? Because there's a lot of things I'm sure that you want to change. But any improvements to 690.12 or PV hazard control 3741?
Yeah, well, yeah, I want to be in control of everything because I'm a control freak. But no, that's stupid. That's why we have standards panels, which are now called technical committees, and we have code making panels, and we bring people together from a wide variety of backgrounds, and these are very difficult situations. So I like David Wolfert's view of education. It would be great if we could download information into installers' brains and that they would instantly know what to do. What was that, a Schwarzenegger movie? Anyway, I like the concept. You just kind of no, that was Terminator 2 or something. Anyway, so yeah, the ability to download information so everybody does things correctly. That's the problem we have in safety, is that, you know, even if you have everybody do everything perfectly, we still have problems. Now we can dramatically reduce problems, and that's what this is all about. And everybody wants to snipe it at safety regulations and things that come down the road. And well, you know, back in the good old days, we didn't care about what the voltage was. We didn't care about, you know, where disconnects were, where we had overcurrent protection. We just let it rip. And it's like, no, we've made massive improvements over time. So it's completely unfair to say that let's roll back time and let's do it the way we used to do it. Now, have we made perfect estimates on where we need to take safety in the future? You know, of course not. There's no way to be perfect in that arena. And that's why we have good, lively discussions on these things. But I believe that we're on the right path. I believe we are moving in the right direction. I believe that we have done a lot of the right things. And so I think, you know, my perfect world is to continue to tweak where we're at right now. You know, if there's things where the pendulum has swung too far in one direction or another, you know, work together on bringing it back to where it needs to be so everybody is clear on it. And so that's one of the reasons we're doing this panel discussion, this workshop. You know, we're talking about these issues because if we don't talk about them, if we just sit in our little silos or get in our little trenches and snipe at each other, it's not going to get us anywhere. And so we've made some massive improvements. 3741 is a great start. To say that it's done is absurd. I mean, anybody who worked on the standard, and we've got a bunch of people not only on the panel but also in the audience that are on the technical committee, to say that it's done is absurd, absolutely absurd. It is a very difficult standard, but it really made some massive strides to really drill down to what the really important issues are. Now we know what the important issues are. Now it's about the devil's in the details of how do you apply it. And so that's really, you know, if I were to say a perfect world, would be that all certification agencies were intimately involved in the development of the standard, knew exactly what it meant and were able to perfectly apply it to any product that came across their desk. We're not even close to that right now. And so that should be a caution to people. As you select a system, and if they say that there's 3741 compliant, well, ask a few more questions and realize that when somebody says they're compliant or has received a certification, those certifications are not rock solid in time, okay? There may be a decision from the technical panel that says this wasn't clear enough because we're seeing people do it improperly. We're seeing certifying agencies not understand the standard clearly. So we're adding some language here to make sure that they get it right and they get it clear. And so for those naysayers out there that say, we should just let it rip, be careful with that, because we have to understand that our success in the solar industry has brought us to a place where it matters way more what we do than when I started 35 years ago. When I started 35 years ago, and Jason started 30 years ago, and other people, Jason Fisher and others, he started a long time ago, we were kind of in our own little ghetto, and we did our own little thing. Now we're in the real world, we're around real stuff. And that's why, back 15 years ago, I started preaching to the solar industry. We got to bring the fire service in on this because they've got lots of questions. They're legitimate questions. We need to work with them. If we work with them, they will be good to us. If we don't work with them, we don't know what will happen. And so that's why we have been working with them very closely, very effectively. And they have been very helpful in the process. And they have not been going crazy and saying, oh, you should just, super duper safety. They've said, okay, these are the things we're concerned about. And that's what we're trying to address in these standards. And in the electrical code, there's things that we can do in 690.12. We've made some massive improvements in 690.12 in the last 2 code cycles. And so in rapid shutdown. So we should continue to look for opportunities where we clarify why it's important, where it's important, what places it doesn't need to be applied. All those things are really, really important. And so just like anything in the solar industry, tweaks that improve things by measured differences and improvements is where we need to go with this. And when we see things that are out of whack, it's our job, at least it's certainly part of my calling in the industry for 35 years as an ambassador of this amazing technology, to say, okay, guys, let's pull this back a little bit. I get where you're going with this thing, but when we wrote this standard, we said straight up that these kind of things were not going to be allowed, and why are they being allowed? So, okay, now let's sit down, look at them, and let's go through the process, see where things went wrong, make some minor adjustments. And even the products that I disagree with today, I believe could be brought into compliance, in true compliance of the intent of the standard, with a very little effort. And so it's not like they're way out there and you got live wires hanging all over the roof and firefighters are just going to get shocked everywhere. That's not the issue at all. It is, let's be clear where mistakes have been made. Let's fix those mistakes so that they're not made again, and so that everyone isn't encouraged to go down this path that is where a mistake was made. So that's my world in a perfect world, and it's a messy world. It's a messy world that we live in, and we all have to fight to make it better, improve safety in the right ways.
Thanks, Bill. It is a messy world that we live in.
Can I just add to what Bill said? Because I know obviously we're talking about firefighter safety, right? But I think the goal here is to not have a fire, right? So why choose a technology that could potentially, the conditions are right, as opposed to a technology that basically, for the most part, as far as I'm concerned, eliminates it? Because it's not just the firefighters on the rooftops, right? It's the people inside the building. It's what happens when there's not not firefighters on the rooftop. It's what happens when there's an arc fault, or what happens when there's a ground fault. You know, great, the inverters turn off, right? But what happens to the live conductors? They're still on. They're still up there. They're still arcing, right? And you know, with the SolarEdge system, you know, for example, you know, the inverters are the ones that are determining what the optimizers are doing within the array. So to have that extra layer of safety, because I always said, like, SolarEdge actually it more or less exceeds the code, right? Because now I'm not worried about somebody pushing a button at the ground level to make everything safe on the roof. Everything's safe on the roof continuously because the inverters are looking for these things, right? They're looking for ground faults. They're looking for arc faults. They're looking for, you know, something that happened within the array that is causing it to not be safe, and it's shutting down. And it's shutting down to a level that's making it safe for anybody to go up there, regardless of whether or not it's a firefighter or an HVAC technician or an O&M team or whatever the case. So, I understand that the code is geared toward firefighter safety, but, you know, it's not necessarily only firefighters that are accessing these roofs. You know, it could be anybody. And that's what also makes the case to have this standard a little bit more defined and clear, because not everybody that's up there is going to necessarily be trained in what they should and shouldn't be touching, unfortunately. Now, you would say that, you know, somebody that doesn't have the experience with solar shouldn't be touching solar. Yeah, that's fine. We get that, right? But, you know, these things happen. And, you know, again, it's what do you want? If you have an arc fault on the roof, or if you have a ground fault on the roof, what do you really want to happen? Well, in my estimation, I don't want anything to be able to necessarily cause a significant thermal event if that's the case. So that's where I'm coming from like an owner's engineer. Yeah,
yeah, thanks, David. Good point on the stuff. It's a little bit beyond 3741, but it is safety related. So yes, having the DC optimization or MLPE or some electronic device can be made so that it does shut down the array upon another fault. But I'll circle it back around to 3741 so we can keep it focused on that. But very good. Sure. Bill, looks like you might have a comment. Did you have a comment, Bill, or were you just?
Oh yeah, well, just to add to that, you know, let's talk about safety real briefly. We've dramatically improved ground fault detection over the last 15 years. If we hadn't have done that, we would have far more fires on rooftops than we've had. We've adopted, in a very messy way, arc fault detection, which was a huge challenge for a long time, and we knew that was going to happen. We were very hesitant when we put that out there, that when we put this in the code, that we knew it was going to be a challenge. And arc fault detection has improved dramatically over the years. We're now getting to a place where arc fault detectors are working well. Are they perfect? No, it's a very challenging thing to do, but our ground fault detectors are working well. And so getting into UL 3741 and saying, okay, these are some things that we can do to improve things further, specifically for firefighters. And we do have to be very, very clear that the standard and rapid shutdown is specific for firefighters. Does it mean it doesn't have other benefits? That's not the issue of the code and that standard. But it does show the way toward improving safety. And so can we utilize some of these things for other areas of safety? Sure. We're not going to necessarily draw the line directly to them, but I think to Dave Wolfert's point is that if we can improve safety in all these different areas, reduce fire hazards, reduce firefighter hazards, then we're on the right path. We're doing the right things. And for those that want to provide a greater level of safety for workers on the roof, for people washing panels, things like that, then now they have a suite of options available to them that were fundamentally not available 15, 20 years ago. And so, and that's also the reason why the codes and standards and 3741 is intended to be fairly open in its approach so that it doesn't constrain people to a certain idea. You know, if you love SolarEdge, great. Keep using SolarEdge. But if you've got other ways of doing it and you've got good products and you've got good methods, then use those. So that's really the message of this whole webinar. And let's get to the questions, because you got some good questions out there. This is, like I said, it's a messy world. It's not black and white. We can't say that, oh, SolarEdge is the only way to do it and everybody else is crap. That's not true. It absolutely is not true. Nor is it to say that, we should throw caution to the wind. So let's dive into questions and see what we can talk about.
Yeah, sounds good, Bill. Agreed. So some of the questions here are around voltage. Can you go over 80 volts, for example? There was another one earlier on. How can 1,000 volts be safe versus 80? So why don't we talk about voltage segmentation versus mechanical means of protection and how both are allowed under 3741. And I'll bring up a graphic if I can. Does somebody bring it up? Perfect. So this is just to help so people can see the voltages. If they're not familiar with the standard. So this is the 2-module segment. We'll call it segmentation, where the highest voltage is reduced to 120 volts DC. And the home runs are at 30 volts DC. Remember, this is after rapid shutdown, okay? If you didn't have that voltage segmentation, the voltage would still be at the string voltage, roughly 1,000 volts, and require some additional means of protection via the standard. I didn't show that in this picture because I didn't have a good picture of it, but if you could imagine some other means, and I'll let the panelists discuss the details of how to do that. So this is just to help visualize what that means. Bill, you're probably the first one I would pick to address that question around voltages versus other means.
Yeah, well, I've used this term segmentation of the array rather than module level electronics. I just don't like the term, particularly because my friend Jason Fisher doesn't like the term, so then I don't like the term either. So it's really more about can you break the array up into smaller pieces that are more difficult to create a problem, and that's what voltage segmentation is about. And so the standard does deal with that and look at the worst case voltages you could get in certain situations. And so we have mid-circuit interrupters, we have 1, 2, 3, 4 module switches, things like that, various ways of doing this array segmentation. Mechanical means are trickier because we have to figure out a way to keep live conductors from coming in contact, especially with things like conductive metal surfaces, like module frames would be a good one, or grounded metal surfaces. Now, our module frames are, in general, according to the code, grounded. However, UL 3741 doesn't necessarily require that. And so by having grounded metal all over the place and having live conductors all over the place, it makes the mechanical protection a much more difficult path. And so that is the rub right there, is that what is sufficient mechanical protection to prevent a firefighter from getting themselves in between all this stuff, where we have live conductors inside the module, where you put a tool through that, you are instantly connected to those live conductors inside the module. And then if you have a grounded piece of metal right next to you, now you can complete a circuit. And so that's why I say, when we were devising 3741, the idea that you'd have grounded metal frames everywhere was seen as, well, that's not going to work. You would have to do something other than that. You'd have to protect the frames from anybody coming in contact with them, unground the frames, put a coating on the frames with that ungrounding, something like that you'd have to do. And that's why everyone is talking about some of these solutions that are coming out with grounded metal frames and full voltages, because it seems to smell fishy. And the reason it smells fishy is because it's a fish. And that's kind of it.
Interesting.
Go ahead.
That's a good one, Bill. And I think that I'll ping Tony now, because you talked about something important, which was the official term in the standard is firefighter interactions, right?
Yep.
And how likely is it that firefighters might interact with the array? I think that the standard really talks about falling on the array with a tool, without a tool, touching another grounded part, as Bill talked about. How does that play out in the real world, Tony?
So yeah, good question. When the firefighters are on roofs, especially flat roofs of commercial properties, and if they're up there for an actual fire, there's a lot of smoke. It reduces their visibility. They're carrying a lot of equipment. Our mask actually reduces the visibility as well. So there is the potential of them falling onto an array if they're walking along those pathways. As far as the fire incidents, if there's a fire incident on the roof, I always teach them to use the reach of their stream, which, based on the studies, that's the safest practice for them to eliminate the possibility of electrical leakage back to their nozzles and electrocution. So after the fire is extinguished, during the investigation or during the overhaul, they will be within the array, within those components, probably trying to move some stuff around to make sure they've doused all of the fire and any of the embers that are left. So the reality is they will interact with the systems on a lot of these roofs. Residential systems, it's a little different because of the high pitches, but that we're seeing more occurrences of fires across the U.S. Over the 10 years I've been teaching. I originally started with a few fires here and there, but now over the 10 years, I'm starting to see more, and I'm starting to see some in towns that I've actually, in states that I've taught, where they've reached back to me and said, hey, we had a PV fire, and thanks for the training that you gave us, because we were able to keep safe, we were able to shut things down and handle the incident with no injuries. But it's, again, there's a lot of firefighters out there. There's a lot that don't know what the systems have and how to operate around them. So a very small group actually are educated. But the reality, as I said, is they will interact with these systems. And if it's accidental or if it's on purpose, it's going to happen.
Yeah, thank you for that perspective. And so I think that we were just talking about voltages a minute ago, but what it really comes down to, I think, is the hazardous energy that's contained within the array. And so there's kind of two schools of thought here, and both can be compliant with 3741 and get evaluation. One is to reduce the energy level, right? That's voltage control or segmentation or DC optimization, whatever term you want to use. And the other school of thought is prevent contact with, or provide separation and wire management and things like that to prevent that interaction that Tony was just talking about. So I think I'd like to kind of go, I see a lot of questions here about, talk about other ways of doing 3741 versus DC optimization. So great, let's go down and talk a little bit more about what a mechanical system would need to do. And so one of the, I'm not trying to design anybody's systems here, but one of the things that I guess we'll talk about observations, right? One of the things we've seen in the field is dependency on wire management components or protective wiring components to maintain separation of conductors or prevent access to those conductors. But those conductors are still energized. They still have hazardous energy. And I'll just open this up to whoever wants to answer it. Are there any thoughts on the pros and cons of that approach, leaving the energy there versus turning the energy off?
Well, I think in what I was talking about, the idea of mechanical means is just more challenging. And I believe to do it correctly can be expensive. And so, ultimately it is going to come down to options based on cost effectiveness of providing the hazard control necessary at a cost that is reasonable. And everyone, people don't like to talk about cost in the context of safety, but let's be real. It is the real world. So we have to understand, okay, if we have options, how do we get there from here? And so, we have been using, plastic wire ties for decades and metal clips for decades for cable management. And those are pretty rudimentary methods, by the way. There's some much better methods out there, and some of those are being used for sure. And it's challenging with exposed cables. How do we train them? How do we protect them from coming in contact with grounded metal frames, with grounded metal supports and things like that? And I think that is, therein is the issue. When we talk about option 3 that was in 690.12 for compliance inside the array, which is often called the BIPV method, building integrated method, the idea of concealed conductors and things like that was that these, there wasn't any grounded metal anywhere within the array at all. And we had to pay attention to where grounded metal was outside the array and couldn't be within 8 feet of the array so that somebody couldn't touch grounded metal at the same time of engaging with live conductors. And then those conductors, certainly in BIPV systems, are generally concealed. They're concealed underneath the array. However, there's other ways of doing it with a non-building integrated application where we absolutely conceal conductors. Is it easy? No, it's difficult with exposed conductors. And so that's why I say, we have some early ideas. They're trial balloons, and there needs to be an adjustment to say, okay, that's not what we're talking about. A wire tie that has an offset from the frame. We look at the chart that is not in compliance with option 6 on the chart that says that you have complete isolation between grounded metal and conductors. That's not true. And so it's just a misapplication of the standard table. The table is there for people to give some ideas on what could be in compliance, but somebody could obviously misread that table and say, oh, well, this meets the requirement when it absolutely doesn't.
Great, thanks, Bill. And we're running short on time, but I want to let David comment real quick on something you said. So we talked about wire management, David, and I'm sure you've got a lot of experience with that. What about some of the techniques that we've seen in the field, zip ties or other components that are used to manage wires that previously were just for typical O&M purposes and typical aesthetics, but now those components are being depended on as a listed safety component of a 3741 system. There's not I'll say there's not an automatic self-check that occurs with these types of components. How frequently do you feel, in your experience, those things would need to be tested or inspected, in comparison with an electronic system that has an automatic self-test?
See, I don't have to worry about those things because I have MLP that shuts everything down if there's an issue.
No.
So, I know that's the kind of the cheap way to answer that, but yeah, if the integrity of your system is going to be compromised based on a plastic wire tie breaking, we've got a problem, right? Like that's not going to fly. And you could talk about they're rated for UV, they're rated for this. This is a common thing I always get. I said, okay, well, we use these plastic wire ties, or we use these. And I said, okay, great. How are they rated? Well, they're rated for UV. I said, okay, good. For how long? For how long is that going to hold up? And then everybody goes, well, for 20 years. And I go, you've obviously not seen these things go through thermal cycling, hot, cold, humidity, everything else that's up on a rooftop in different climates. They're not going to last. I mean, it's just how it is. And again, like I said, if those things are compromised and I have a SolarEdge system, I don't need to worry about it. Or it's something that has MLPE and shuts down if there's an issue.
Is there a recommended inspection interval if you have those types of things? I'm not familiar with.
If our O&M teams have to go out there and check every single plastic cable tie to make sure it's functioning properly, that's not going to work, right? It's usually just spot checks throughout the array, right? And we're looking for wires that are potentially hanging down or rubbing up against something or whatnot, right? We still do that even with our SolarEdge systems, right? It's not something that we just say, oh, forget it, we don't have to worry about that. No, we'll still do that. So just because we want everything neat and tidy, we want everything, organized, and again, that's a representation of the quality of the system as far as I'm concerned. But but we see it all the time. I mean, you're walking through the array, this wire hanging down, or this wire's hanging down, or for some reason I've seen people moving ballast blocks, which I have no idea why people are moving ballast blocks. Maybe it's to get underneath the array for some reason. I don't know. If they had to replace a panel, I'm not quite sure. I use the example, sometimes on these rooftops, I see chicken bones up there, which I immediately was yelling at my installers, like, guys, who's eating up here and throwing their chicken bone? It's not that, it's seagulls dropping them, and potentially breaking the panels. We've had a couple panels break. I don't know how these seagulls are lifting these heavy things that are dropping on panels and causing them to crack, but I see impacts on there. And, again, we've replaced a panel, and, it was an O&M team, and they rocked the panel in on a panel claw system, and everything grabbed, and they did it, and there was a wire pinched, and they left the site and turned everything back on, and all of a sudden the inverter said, hold on, I got a fault. And had we not had that technology up there, again, that would have been a problem. So I don't have to worry about plastic ties failing and potentially compromising my system.
Thanks, David. Sorry to end it, but we are a little bit over time. And I'll just say thank you to all the panelists that have joined. This has been great, and I appreciate it. And thank you to the audience for all the wonderful questions. We did not get to them all, but we will send you emails and address those specifically and get some dialogue started. Lots of great questions here. Sorry I couldn't get to them all. We have about 50 questions. All you, Kelly.
Yeah, no, thank you everyone for your participation in today's webinar. And the webinar will be shared with everyone, so you can view it again, and our presenters may reach out to you afterwards with the answers to your questions. So thank you to SolarEdge for sponsoring today's webinar, and hope to see everybody at more Solar Power World webinars in the future. Thank you so much.
Thanks, everybody.